check this out. We have got so much working right now with our Shader Doodle application. I mean, I think the hard work is really behind us, and we have some interesting problems ahead of us, and we have some interesting things we can learn about Lit ahead of us as well, especially in this new TypeScript environment we're working with. So I want to do a quick recap of what we've done so far, which again is a lot, of course. We have this is Shader Doodle right here operating on our page right now. And this multicolored, animating gradient is actually kind of boring compared to what Shader Doodle can actually do, and in general, of course, boring compared to, what WebGL shaders can accomplish as a whole. We're on our way there, but, I had the bright idea, maybe it's not so much a bright idea, to make this into a GIF. And again, we have some text up here we can edit. This is a GIF, but why? But then that's the question, right? Why are we making GIFs when this component is so awesome on its own? Again, I felt we should just cram everything into this application, make some GIFs, make editable shaders. But in the end, I think we're gonna have a kind of a cool application and a good intro into what Shader Doodle can do. But of course, we have to wire a bunch of stuff up. We have some drop-down menus that let you populate shaders and switch this content out right here. We have some textures that you can load if the shader supports the textures. We also have this record and save GIF with some options right here. And of course, we can change the color of our text. We have to get all of this in place now. But just like in the last episode, we're going to use some reactive lit properties again, but we're going to use them a different way because we are using TypeScript now, which does support decorators. So let's get to it. Let's think back to episode 1. We introduced this concept of reactive properties. For example, in this project, we want to have a text color. We want to be able to have this text and be able to edit the color of this text with these color pickers. It's easy to do. We did it in the last episode, and we do need a reactive property for this. So if we were using pure JavaScript, as we did in our last project, we might want to say, hey, let's add a static get properties method on this lit class, and return a list of things, textColor being the first one we want in our list. And then we have to declare it, which is a drag because it's separate code. We'd have to have a constructor, and then we'd say this.textColor equals, let's start out with red, so FF000. What if there was an easier way? Well, we are using TypeScript, so we can say textColor, and we'll annotate it as a string because that's what it's going to be. And then we'll say it's going to be red, FF0000. So this is a property we can use. It's just a normal class property. It's not a reactive property yet. And remember, reactive properties, Lit is always watching. And if it's a reactive property that changes, Lit is going to see that. And it's going to say, hey, let's take a look at this render function. And if textColor is used anywhere in here, we're going to re-render that small little piece of it. Not the entire thing, but just the little piece where textColor is used. So what we're doing here is we're doing the same thing. We're initializing textColor to be a certain value, and through the decorator, we're declaring it to be a reactive property of type string. Now, of course, we do need to import property here, and it'll all be cool. And so, yeah, this is the main reason I wanted to use TypeScript, because Lit is a little more elegant, right? We're declaring a custom element with our decorator. We're adding a property here, a reactive property. And I just like this syntax. Now that we have this reactive property in place, we can just add the value and input event onto our color area and color slider. So as the user drags, not when the value gets accepted and changed, but as they drag, so you can see this responsively, we're going to grab the input event and set the text color to be the target, the value that's coming from this event. And then the color of this color area is going to be tied to the text color we just added, this reactive property. And we're going to do the same for this color slider as well. So I think that's going to work. And then lastly, we just need to, we're going to add some inline style here. The color is going to be the text color that we just added, this reactive property that gets changed by the color area, the color slider, and this is all going to feed into this content editable field here. So let's see this in action. And already we can see it's set to the initial value of red. So let's start changing this. And we can see this reactive property, this text color value in action here. So we can change it to any color we want. And now that we're here focused on this content editable text, let's add the actual text content here, the text value. So let's make another property here, and we're going to call it text. And it's going to have an initial value of Shader Doodle. It's protected. Why not? We're not going to make it public. We only have one component. There's no reason to expose this to the outside world. So it's going to be protected or private, whatever you prefer. We're not going to make this a reactive property because I think you'll find we don't need this particular instance of a property to actually be reactive. So it's going to be Shader Doodle. Let's add the new input event, and we'll tie the content of this div, this content editable text div, to the text variable. So this.text is the content, and then we're saying on input. So while the user types, they'll be generating an input event, and the text property, the class property, will be set to the inner text of the target of the event, which is this text field. And when we save this, we can see that right away we have Shader Doodle, which matches the initial value. Now again, it's not reactive because we just need to make sure this text property is updated continuously. So when we do go to render the GIF, it's going to show the right text. Now, if we need to see this visual change of the text anywhere else in our application, anywhere else in this component, yeah, we'd need to make it a reactive property and re-render everything. But given that we just want it to have the latest text content when we click that button to generate that GIF, we don't need it to actually be reactive. Now, the next thing I want to focus on with these reactive properties are this number of frames. So again, this number of frames is when we record and save this GIF, we want to record this many number of frames, so anywhere from 1 to 20. And then the milliseconds between frames. And we want this to be a reactive property just so we can update this user-facing text right here. So it's not so important that we update this, but it's a nice user-facing message. So let's do that. I'm going to do something slightly different though here. We're going to add these two properties as state decorators. And so we're doing frames to record and milliseconds between frames. So let's go up here and import state. Now, of course, your question probably is, why are these state and why is this a property? Well, you know what? This property doesn't even need to be a property. It probably should be a state because we're just working with this one component again. But state is a reactive property, but only for internal use within your component. So given we just have this one component, there's no reason to say we want this to be a property. It's not going to be exposed outside this component. So it can just be a state. So now that we've added these properties, these reactive properties that are decorated with state, let's add this value and its input event to the slider. So the number of frames slider, we can say value equals frames to record, that property, that reactive property, and we'll listen to the input event and say when the value of the slider changes, we'll set frames to record. And we're going to do the same thing for this slider below it, the same thing with milliseconds between frames. So here we have it, the value and the input event. And like I said, we're updating this field label right here, which says we'll record X frames at a rate of X per second. Let's replace that with the actual variables inside the string template. So we'll record frames to record frames at a rate of milliseconds between frames divided by 1,000. So, and that's per second. That's why we're dividing by 1,000. And sometimes when you're scrolled down to a piece of code, you just gotta make it work. So let's add the click handler for record GIF and just add a dummy function that just alerts to say we're recording the GIF. And here's that placeholder function right here. Again, we're just alerting when somebody clicks that button. We'll fill this in later. Now I'm gonna add one more reactive property that will, add with the state decorator here. And that's the current shader we're using right now. We do need to import shaders from our shaders TypeScript file here, our shaders list. So let's do that. And I didn't go into depth on this before. I just copied and pasted all this stuff in. But if we look at the shaders file, we have each shader here, we have a vertex and fragment shader as we've seen before, but each one has a name, a gradient or a fractal pyramid, But if we go all the way down to the bottom here, we export the entire list of shaders. So this is a handy way of, populating our combo boxes or our SP pickers. So since we've already imported every Spectrum component we could possibly need for this application, we have the SP menu item available to us. So we can take our big list of shaders and map that so that each shader generates an SP menu item where the value is the shader ID, which is going to be an integer, and gives us the shader name as the display. And then we can say the current value of this picker is the current shader dot ID. So for reference, we can go right back up to our current shader, which is, we took that huge shaders list and we said, just get the first one. So when we get that first one, that happens to be the multicolor gradient one. And the ID is 0. So we're referencing these IDs just by, a simple, index of this array. So when the user picks a new shader, we're going to listen to this change event, and we're going to look at our big list of shaders and look up at that ID using just an ES6, find function and find that shader that matches the ID that the user picked. And we're going to set that to the current shader. And again, the current shader is defined right here, which we're starting with the very first shader. And now one more thing for this picker, we're gonna set the label here. So label equals custom. And so I'm adding this label equals custom because yes, we have a main list of shaders, but what if the user edits the text? So if the user edits the text of the shader, it's not gonna match any shader that we have in our list. And so we don't want to show that as the current shader. So it's going to fall back to this label, which is custom, and it's going to indicate that your shader can't be found. You're editing it. Now let's see what this is like right now. So yeah, right away we can see simple gradient. It's the first shader in the list, and we can't actually open our menu. I think there's a bug here. So let's check this out. And if you remember, process is not defined. This is a lot like what happened in our last episode when we were trying to open up this picker and it appeared in the wrong place. Well, this error is manifesting itself differently, but the message is the same. Process is not defined. And again, this process is not defined. It's coming from a third-party library for a floating UI. So it's how Spectrum Web Components manages its overlay system. So the overlay is the menu items appearing over the UI. And so how do we fix this? Well, in the first episode, we fixed it by hacking it, by faking process to be an object in our global space. Let's not do this time. Let's actually do things the right way using our web dev server config. So as we go to our web dev server config, there's something super interesting here as we tweak this to make this error not happen anymore. You remember that we added plugin lit CSS to our list of plugins, right? And this was a rollup based plugin. As we discovered, it's pretty nice that Web Dev Server can use any number of rollup plugins. It's pretty amazing. But there's something special here. Node Resolve. Now, Node Resolve, if you remember, if we look at our imports on our Doodle component here, we're importing lit code. We're importing lit. And like we covered in the last episode, we're not doing going to the node modules folder, however many deep that is, and trying to find the thing we need to find. Instead, we just type lit and it finds it for us. So this is Web Dev Server saying, hey, we found lit in your node modules. We're going to resolve lit against, // node modules / lit, whatever. It's very shorthand. So this is node resolve. But the fact of the matter is, this is actually a plugin too. And instead of just saying true to have it be on, we can actually pass in an object. And inside this object, we can have some parameters to specify how it works. And one of those parameters we can use is export conditions. And so when we use this, Web Dev Server is going to think, okay, I'm in production mode, I'm in browser mode, we're going to operate like a browser, and we're not going to operate like Node.js where we're looking for process.env or whatever it is we're trying to find. So this is how we can solve that issue. Because we're changing this configuration, let's start Web Dev Server all over again and see if this fixes the issue. And yes, it does. Our menu opens. We can see all of these menu items with the shaders that we have in our big list of shaders right here. Okay, so that felt like a lot to explain. We have one more thing to do before we finish up this step. And, we already filled out our menu of shaders. We have a list of sample textures to use too. So some of these shaders, they can be used with textures. So let's just populate this with a list of textures we could use. But first, we need to we don't have any textures in our project right now. So let's go and copy and paste some images right in here under the assets folder. So I've added a few space photos here. We have the Jupiter spot, we have a red dwarf. So yeah, we have some good space photos we can use here. So we can add all of those photos in the same way in our picker right here. We're gonna have this first item, however, be no texture. So when we pick a shader that has no texture, this picker is gonna display the right thing. But the rest, we're gonna add my webcam, which is gonna be a thing we can do using your webcam with this. But also all the photos we just added as well. So this is going to be all of our menu items in this picker. So then we're going to set the value of this picker where the current shader dot texture is the current value. But if there is no texture, if it's undefined, it's going to say no texture. And lastly, we do want to have a change event here. So on this change event, we want to listen for this change event. And we want to change the texture on the current shader, but we don't want to alter the original list. So we're going to create a deep clone of the current shader object, assign that to our current shader, and then change the texture on that. And so what's going to happen is this is going to show up as a custom shader in our list. I think that's plenty. I think we've done a lot here, so let's stop there. We can actually see this in action right now, I think. We have no texture here, but we can choose my webcam, we can choose any of these other photos right here. We've done a lot of work, but there's more to come because when we try to choose one of these shaders, nothing's happening. We just have the menu active. It's not actually changing anything. So this is next to come. We're gonna wire this menu up, switch out our shaders in Shader Doodle, and eventually we're gonna record the GIF as well. So stay tuned. We have some more work. We're just getting to the good bits. It won't be long before we have a fully working app. So see you then.